Machine learning algorithms these days are widely used in data science. Researchers can predict experimental outcomes, but they often lack clear data-driven guidance on which experimental parameters to change to achieve better results. Predictive models rarely answer two critical questions: which experimental variables have the greatest impact on the outcome, and what changes to those variables are most likely to improve future experiments. The DiCE and SHAP Explainable AI Research Assistant combines explainable AI with counterfactual reasoning to identify the most influential features and recommend meaningful parameter changes that help researchers design better experiments. It tries to think like a researcher and answer the questions like what should I do next to improve yields, to increase efficiency above a certain threshold, for example. DiCE and SHAP Research Assistant is an interactive glassmorphic Flask-based web application designed to validate datasets, train random forest regressors, perform SHAP and DiCE analysis and optimization, and render the outcomes on the screen. And the schematic diagram of the ADK workflow is shown here. So user starts with uploading the dataset into the system, and which invokes the validation node. Validation node will check the dataset, and it can also perform size-aware sampling since the model is being trained in a real time. The validated dataset is then passed to the trainer node, which trains a random forest regressor algorithm model. Best fit model is then passed to SHAP and DiCE nodes, which run in parallel. So SHAP node performs the SHAP analysis, DiCE node performs the DiCE optimization, and the results are then merged and combined and rendered on the screen. And here is the live demonstration. So it is running on a local Flask server. Flask server, so the user has an option, needs to enter the target column name, which in this case is going to be usable cons2. And I'm going to enter a realistic dataset, which I was working on for Carbon Copies Foundation. And once I select the file, I hit upload and validate. And here, the banner here will show the exact sampling algorithm that was used, if any. This column here allows to select the desired target ranges for DiCE optimization, how many recommendation alternatives do they want to see. Here we can select a threshold, and we can choose the optimization strategy, and we can either keep certain variables unchanged or select, we can also select the data types, whether float or integer. The number of days is an integer, of course. And then we can select ranges for the recommendations, for the new recommendations, and hit Run Research Assistant, which then will train the model, calculate perform Shapley analysis, and generate DiCE counterfactuals and render the results on the screen. So these are the SHAP plots, which demonstrate the feature importance in the data set, and you can also see the performance of the trained model, as well as the correlation metrics, and the training R-square and OOB scores are also shown in the cards. And of course, the most importantly, the table below shows the alternative experiment suggestions, recommendations to push the predictions above the certain threshold. And with these recommendations for the new experiments, you can interpret, explain, and optimize, and you can go beyond prediction and toward the discovery.